first presenter is Mr. Rusty+Houston. He's been involved in subsurface drip irrigation for approximately 16 years. He and a partner started DSI in 1996 in Lubbock, and in 2002 he bought his partner out and is now the president of the company. He's installed above ground and subsurface drip irrigation for all types of orchards, vegetables, and row crops in Texas, Colorado, Arizona, and New Mexico. And this today is a pretty pleasant gentleman to deal with, so I'd like to invite him up here now, Mr. Rusty+Houston.
Glad to do it.
Thank you, Nick. Thank y'all for allowing me to speak today. And if y'all want to get your afternoon nap, I understand. Right after lunch is kind of tough to do, but I'll do my best to kind of explain some of the things that key components of drip irrigation, and try to explain how we think and what the reason we think they're important for the drip irrigation system. I know the speaker after me is going to go into a little more depth about some things like that. So hopefully between both of us we'll really definitely cover some of y'all's questions. Key points of drip irrigation: design, filtration, and then going through the key components: your pumps, your booster pumps, injection pumps, chemical pumps, things like that. First of all, we'll talk about the designs. When looking at your designs, you need to look at the crop requirements. What type of crop are you going to plan on growing this? Are you going to do rotation crops, things like that? What are your water sources, available water that you have there? Is it one well, two wells? How old are the wells? Do the wells have much pressure? There's a lot of things that you need to look at as far as what available water you have there. And like I said, it follows into the water source. Looking at the pressure pumps, is it algae water, is it clean water, subs, things like that. And once you've chosen, you kind of have an idea. Most agri farmers know what their row crop is going to be, and we'll look at the type of spacing they want to do. Majority of cotton is done on 80-inch centers. A lot of stuff is a lot harder to germinate on the 80-inch centers. So if you're on 40-inch rows, it may be better to look at the 40-inch take spacing, so you're able to, on a dry year like we've had this past year, be able to germinate the crop and not have the worrisome issues of actually getting that crop up. With that, you're going to need to look at the topography, especially if it's on a slopey ground and your row spacing need becomes more critical. You need to understand that if you're going to be able to meet the PET of that crop. And this is some of the things you need to look at in the beginnings of the design. There's a lot more questions that need to be asked. Those are some of your basic starting questions you need to be looking at when you start doing the design for drip. GPS systems are very critical when it comes to drip irrigation. Not only for designing your system, getting your topography, knowing your elevations, knowing your water source locations, knowing your electrical source locations. We go out, most irrigation companies for drip go out and actually map the field. So we can bring that back to the office, do a complete design, run the numbers on it, make sure it's efficient for the crop that's the water that needs to be for that crop. Also the GPS system, I do not recommend putting drip plowing in the tape out of the guidance system. It's hard to get back on your road, especially if you go on 80s, 60s. It's almost impossible to get back on the road. You can do it, but you'll never be perfect for that first year without using the GPS system. So use the GPS system, guidance system to plow in your tapes, list up your roads. Keep a record of it. I know that most systems that I've seen, they'll give you a disc of your farm if you don't have your own GPS system. Save that and lock it up, because if you ever do get off the road, it's a good way to get right back on. This is the design that we do, and then you can see the topography lines. Figure out my corner here. These topography lines showing the difference in how the elevation drops and putting the design together. If you look at the design of this, we multi-zone this. It's kind of like a yard sprinkler. The water's the front side, and the front, middle, and back, things like that. You got to think about it like that. You have multi-zones. Well, in this field right here, 50 acres, you water that entire 50 acres every 24 hours. And every 24 hours, you're putting out 1/1600 of an inch a day. This is on a cotton field. I know that's not a lot of water, but A lot of the majority of the systems in the Lubbock area are designed on the 1600s, 1700s of an inch a day, which meets pretty much the requirements needed for the crop. The good thing about doing multi-zones, if you water, say, zones 1 and 2 together, if your water starts to fall off, that's what you need to look at. If you can do 3 zones at a time, that's much better. You've got that much more play and make the irrigation system last longer. I guarantee you there's no way to go out 3 nozzles. And so that's the only way that we can compete with that issue is going back and designing the multi-zones. There's also advantages to that economically. If you do the multi-zones, you get into less smaller pipe, smaller valves, which decreases the actual cost of the system. Now you can go overboard and put too many valves out there, and so you just need to look at the economics, what best fits you. I'm going to kind of touch base on filtration systems. There's sand separators. There's all kinds of different types of sand separators. We'll get into that here in a second. There's screen filters, what we call manual disc filters, spin disc, and then sand medium. This is a sand separator. It's just a hydrocyclone. Basically spins, throws the sedimentation out to the outer sides, the larger particles are forced down into the sedimentation tank, and the clean water just comes out the top into your next type of filtration you're using. These are set up on automatic flush. They can be on manual flush. Depends on how you want to set it up, how much money you want to spend on your system. They have about 7 pounds of pressure loss across these filters right here. And that's pretty much standard, I think, for anybody that builds these type of separators. There's others called, I think, dumbbell, excuse me. They have a big bell on top. They do the same thing. They have another bell on the bottom. And they're another type of sand filter. This is just what I kind of feel comfortable with using, and we put them on every system out there because 90% of the time, if you're pumping water for below ground, you're pumping some sort of sand. And we need to try to get those larger particles out, and maybe some rust, things like that. A screen filter. This is actually a spin clean filter. That the water is in front of the filter. There's a little spin plate that makes the water as it comes in spin, and it's constantly spinning and scrubbing the filter. This pipe right here. One of the things I really don't like about this filter, it's a good filter, but if you've got any type of sand, this is its sedimentation tank. It's constantly got to be dumping water out. And that is how much water is based on how dirty the water is. Sometimes you just barely crack the valve open, or you may have to leave that valve fully open and then dump the water out. There's also manual discs or screen filters where they just look like a Y strainer. We don't use a lot of these. We might use them in smaller systems. I know a lot of guys, this system here, they put them on very large systems. This filter manual, if you don't know what a disc filter is, it has a little small disc inside of it, and on top of that disc, the grooves go one way, on the bottom they go the other way. And what they do is they're laying sides, crisscrossing, depending on the manufacturer, up to 9 times. And that's like having 9 screen filters in a row. This is what we typically use, in my company typically uses the Lubbock area. The reason I call it the manual disc is the only way that you can actually clean it. I mean, you can clean it automatically with the back flush, pushing the water back is good. But the discs do not separate during back flush. So we call it the manual disc filter. The next one. Disc filtration spin. Different manufacturers make one where they actually during back flush the valve, the disc will actually spread apart and spin inside there to clean themselves out. The main reason I don't use the spin disc filter is we're pumping a lot of sand, and I'm worried about getting sand particles that don't get flushed out there and leaving an open path into the drip system. I feel like the spin cleans are more for the algae type situations. They're both really good filters.